All right. Hello, everyone. Good morning or afternoon or evening, depending on where you're at. I'm on the East Coast here, so it is kind of my morning getting into afternoon. Thanks for joining us for WireMock Live. A little bit of house cleaning, and then we will jump in. If you're not familiar with WireMock Live, we do it about once a month or so, and it is a forum where we walk you through any new functionality, advanced functionality, hidden use cases related to WireMock Cloud. It's really meant to be if you're on the engineering side and you're using WireMock Cloud or exploring using it, how you can kind of get your hands on some functionality beyond the surface level. There will be a Q&A at the end, so feel free to drop your questions in the Zoom Q&A section. It doesn't have to be on today's topic. It can be on anything WireMock Cloud related that you want, so make sure to use the time that way. We will send a recording out to everyone after this. Then for context, I work on product here at WireMock. Dan, who's going to lead the session today, is the head of customer success. And today we are going to be talking about our Open API functionality. Maybe you've seen it, but you're not familiar with everything it can do. Maybe you saw it a while ago and it's been enhanced since then. So we're just going to give you a walkthrough of if you are using WireMock Cloud with Open API specs, how do you get the most out of the product and what can you do with it? So once again, please drop your questions in the Q&A section. And then afterwards, if you want to share this with your team or anyone else internally, feel free to do so. We'll send that recording out within a couple of days. And with that said, I'll go ahead and hand it over to Dan.
Thanks, Ethan. Let me get my screen shared here and then right. So yeah, as Ethan was saying, we've covered some of this stuff before, but we wanted to make sure we refreshed a little bit everybody on the capabilities of OpenAPI functionality inside of the WireMock Cloud platform, especially as we are preparing some new and exciting functionality in the platform that we're looking forward to sharing with you in the near future here. So let's start our journey today by creating an OpenAPI specification style of mock API. And as we go through the demonstration today, I'll point out some of the recent UI enhancements that we've made, just in case you've logged in recently and you're scratching your head as why it looks different or where something might have moved, or maybe you haven't logged in a while and just preparing you for the next time you log in where some of your favorite features might have been rearranged to. So you'll notice some new fonting and styling, bringing it in line across the platform, as well as bringing it into more of a modern styling inside that you're used to seeing in other products. So let's go ahead and create a new mock API. And you'll notice we still have our Open API or REST style of template here. This is the one we'll be using to unlock the features that we're talking about today. So if we come in to create a new mock API, we'll give it our typical name. Let's go with live demo 3 for today. Oh, looks like that one's taken. So let's go 31. 31 is free to be used. So we're inside of WireMock Cloud now, inside of our live demo 31 mock API endpoint. And you'll start to notice some differences for those of you that have been using the platform for a while. A little bit of rearranging, a little bit of new formatting. You'll notice that the new stub and the refresh button have been moved down to the bottom. We'll be making use of those in a moment or two here together. Also important to recognize where the test requester used to live as a slide out on the right-hand side. You'll now find the test requester towards the FQDN of your mock API. So test requester is now living up here as a popover modal rather than a slide out dialog. Those are the first two things I'll point out there. I believe those are the key differences that I wanted to point out in the changes to the UI, but if I think of some more as we move along, I'll do that. So in our OpenAPI specification, OpenAPI mock API style template, we get access to an extra item in our slide out menu bar here. So if we come into OpenAPI, we'll notice that not much has changed in here, but to reiterate what's in here, we have our OpenAPI specification settings. You'll notice right now it's rather blank. It's just documenting the version, what version of the OpenAPI specification this is, what version of the OpenAPI contract this is. This defaults to 1.0. and what is the URL of our mock API. Pretty blank, not much value in there just yet. We'll change that in a moment or two. You can also in here copy and paste an OpenAPI specification that you have for an internal service or third-party service. That'll work just like using the import capabilities that you're used to in the blank style of mock API template. So if we were to import a Swagger OpenAPI definition file, that is the same as if we are pasting it into this text box and hitting save. This text box will accept both YAML formatted, as is the default in the platform. You'll see this is a YAML format, but it will also accept JSON formatted OpenAPI specification documents. Now, also important to point out here is in the settings, we'll be talking through these. One of the incredibly popular and powerful features is the auto documentation of our mock APIs. So as we use this functionality to rapidly prototype, use a mock first style of development to build a new API, design a new API, or even iterate on an existing API, we can enable our documentation endpoint, which will automatically build for us developer documentation on our API that we are designing or building or enhancing here, and back it with a mock API to basically implement a sandbox so that we can practice, our consumers can practice making calls against the API even before it's ready. We'll see this update as we make changes to our OpenAPI specification file. But right now it's rather blank because there's not much to drive it just yet. We'll also get into some of these other options here in a moment. So let's begin by affecting this particular document. So we're going to go on a journey here as two teams, a consuming team of a new API and a producing team, the one that needs to build the new API. And we want to do these efforts in parallel. So with the OpenAPI functionality inside of WireMock Cloud, we advocate our customers to take a mock first approach to designing these new APIs. Rather than getting on the whiteboard and sketching out what this needs to do, or the virtual whiteboard, or sharing around Microsoft Office documents or Google documents to document what this thing should do, let's just work by example inside of WireMock Cloud to actually demonstrate how this new service should work. We'll do that in our stubs pane. We'll create a new stub, and we're going to do a basic contact address book for our demonstration today. So one example would be, okay, how do we get a contact? Specifically, how do we get contact one from our new API that we're designing? Well, the path is going to be, contacts, and maybe we need to pass in a contact ID as a parameter. Using the OpenAPI specification standard here, we're using path parameters for our matching logic. So you'll see our URL match type is path template. We're going to be looking for a get. And because we are doing an example for get contact one, we'll make sure that the contact ID is equal to 1. Now, in rapidly designing this, okay, if we get this request, what should the response be? This is the typical stuff that you have in your documentation when you're writing this on paper or putting it up on the whiteboard. Instead, we're doing it in the WireMock Cloud environment. So we're going to return a 200, successfully retrieve that contact. It's going to be JSON that's returned. And then we can give our example payload of what would come back. So here's our get for contact one. Contact ID, first name, last name. So that's one example. Now notice simply by saving this one example, if we come back into our OpenAPI specification document, we now have a contract that's being built out for us automatically. And if we come back over to that developer documentation page that's being automatically generated, we'll see that we also have an endpoint that's been automatically updated and documented for me. Again, backed by the mock API. So when I send that request for contact ID 1, I get the exact response that we just provided as an example. I can now use this mock API as a consuming team to start developing against this API, even though it doesn't exist yet and the producing team hasn't started to build anything just yet. Let's take it another step further. Coming back over to our stubs, let's give another example. So I'm going to clone this one, and let's do get contact to, because we want to demonstrate a piece of functionality in the way that this new API should behave. In this case, contact to is going to have a slightly different response. So if contact to comes in, we're going to respond back with contact to's information. And contact to information is going to have an extra attribute, the organization attribute. This is just a fundamental design time decision that we're making as a team, that if the contact is not part of an organization, like we saw contact one was not, organization will not be returned in the response payload. But if the user, like contact two, is part of an organization, it will be returned as part of the response payload. Quite a simple distinction here, but important to the consumers of this future API, so they can handle this design time decision and make sure that they're not always looking for this organization tag, because it might not always be there. So we hit save here, and again, our OpenAPI specification document has been updated automatically. Now, what is it updated for us here? Well, it's including some documentation, some examples, but we'll notice that specifically in the response for this path on the get contact, we'll notice that the schema required tags are contact ID, first name, and last name. Even though there is a property that can be passed in called organization, it is not required to be in the response. So you'll see that the platform is able to recognize these small differences and changes in how these endpoints and paths are being built with all of the examples that you're providing, and build a very succinct and appropriate and accurate representation contract, OpenAPI specification contract of that service for you. Now, we can go and keep adding some puts in here and some patches and all the other things that we'd want for our base functionality. But ultimately, when we're done with this design time decision, that's when we might want to push this information into our source code control, the OpenAPI specification document. So we can come over to the synchronize with a Git repository functionality of WireMock Cloud, enable that synchronization, supply just a couple of pieces of information, such as the Git address, what branch do we want to interact with when doing pushing and pulling of the OpenAPI specification document, where does that specification document live inside of our repository, and then what is the key that we're using inside of our Git backed repository, SSH key, in order to enable the synchronization and this integration here. Once we have those 4 pieces of key information specified in here, we can test our connection, and then we'll be provided with, on our document screen, a couple of buttons down below to clone and pull our OpenAPI specification on demand. So it's a very powerful piece there. So we can design this, then we can push it into our source code control. We can now turn off these generations steps, or settings. What you saw here was we updated the OpenAPI document when the stubs changed. So we saw the OpenAPI specification document being built out automatically as we created and modified stubs. Well, it also works in reverse. As I mentioned earlier, we can copy and paste information, or just manually type in information or edits to the OpenAPI specification document on this document tab. And those will be automatically reflected into the stubs if we have this button enabled. Now, best practice here, once we adjourn from our rapid design session, we turn off those syncing or auto update pieces. We sync our OpenAPI specification document to our source code control, and then we start to use what we call validation mode. At this point, the producing team has now gone off and started to build the business logic to actually deliver this new API. They have an OpenAPI specification document that they can use to put into their code generators, to generate the code scaffolding in whatever language they're using. They can put it into SDK generators and automatically generate the SDKs for various different programming languages for this new API that needs to be built. But ultimately, they need to fill in the business logic to figure out how do we get from that get contact one to the response that we saw in the stub that we built. Now the consuming team can walk away and actually start to build a consumer. They have an API endpoint, our mock API endpoint, to start making calls against. And this is where the validation mode starts to come in really handy. So with hard validation mode, as a consumer of this API, mock API, I can now start to make calls against these. And we'll use the test requester to make a call against get contact to. So get contact to, we send it, great. We get our contact to information. I can start to, figure out how to use this and display it appropriately and process it in my consuming application. If I start to actually send something that is not correct into this mock API, maybe I start to send a body into this GET request. Not unheard of. Shouldn't really break anything, but it is a violation of the OpenAPI specification. It would fail contract testing when we do official contract testing. So with hard validation mode on, we see that we get a hard 400 bad request error coming back from WireMock Cloud. It's not giving us the result that we programmed it to, even though we didn't tell WireMock to look at the body at all. The validation mode is validating the request against the OpenAPI specification and telling us that there's a request body, but it's not expected in this request. And that's where we see a hard validation. So it protects us from sending improper requests into the mock API and even into the real API, as I'll talk about in a moment. Now, it also protects us as a mock consumer from creating bad data scenarios. So if we create a get contact 3 to create another data scenario for ourselves as a consuming team, we'll just make the couple of changes here. Contact 3, we're going to come down and say, just use a hard-coded stub for right now, that this is Tom Betty, and Tom Betty is part of organization 4. And we'll click save. Okay, now when we go to actually consume this data scenario that we've just created, we'll use the test requester again, get contacts 3. We'll notice again that we are getting a hard validation error from WireMock Cloud. In this case, it's telling us that the response is invalid and that the organization has an integer as the value of that attribute, while the OpenAPI specification explicitly states that it needs to be a string. So we've created a bad data scenario in our mock API. This data scenario does not conform to the OpenAPI specification that we agreed upon with the producer of the API. So if we need this to actually behave in this way, we know that we need to go talk with the producing team and understand a path forward to making the service behave the way we need it to as a consumer and get that OpenAPI specification adjusted to reflect the changes we need them to build on the producing side. And as I mentioned, once the real service is online and live, this will work even going against a live service. And the way I typically showcase this is we create a new stub. We can go ahead and say that this is the live service. We'll change our matching logic to any method, our URL match type to any URL. We'll raise our priority to the highest priority. So this stub will match everything, and it'll always match it first, regardless if there's any other matches. And then we'll come down to the proxy section. We'll configure the endpoint for our live endpoint. I'm just putting in API.github.com for example's sake here, and click save. Now that validation mode will go against the live system. As a request from the consumer comes into our mock API endpoint, it will be forwarded on to the live endpoint, and the response that comes back from the live endpoint will also be validated against the OpenAPI specification contract, giving us those hard failures or maybe soft failures. You might have picked up that there was another option called soft failures. You'll see those inside the request log here only. Notice that we have these exclamation points. These exclamation points tell us that there was a validation error on this request. And if we come down to the bottom, we can see that it's going to explain to us exactly what that OpenAPI validation error is. And it's even going to pinpoint for us inside of the specification document where that error is being tripped. In this case, it was the organization attribute. We can see that it needs to be of type string with an example of marketing, but we passed in an integer of 4 on this request, therefore tripping the validation. So the difference between hard validation and soft validation is going to be hard validation. The platform is going to send a failure message of 4xx or 5xx, depending on if it was the request or the response that failed validation. Whereas soft validation will still return back the stub's response as you've configured it, but only alert that there's a validation error inside of the request log here. Therefore, you would need to be looking at the request log either via the UI or via the APIs to understand that there have been violations that are occurring against the contract. We call this feature validation mode. With it, you can accomplish full-scale contract testing against either your mock APIs or against the live service once it's available. All right, one other point I wanted to mention as far as the capabilities in the OpenAPI specification style of, OpenAPI style of mock API is the record functionality now works. Many of you might have noticed in the past that the import capabilities and the record capabilities did not work inside of the REST or OpenAPI style of mock API. Well, now they do work. And in fact, the recorder works just like it does inside of the basic or blank style of mock API template. And the value behind this is multifold. We've had customers that have a lot of internal services or just services in general that don't have OpenAPI specification documentation for them, but they want to use type scripting to develop the consumers. But they need the OpenAPI specification documents to do that type scripting efficiently. So using the recording capability, we can very rapidly record some real traffic going against the live endpoints and auto-generate those OpenAPI specification documents for you. And then you can use those OpenAPI specification documents either for validation mode, contract testing, or the type scripting as well. Okay, and then one last thing I'll talk about real quick, we called this out last time. I just want to make sure everyone was aware of it. If you didn't get to join us last time, our documentation has been refreshed and revamped into a new platform that is backed by AI search. So yes, you can just search for keywords as you've had in the past, or you can ask it, contextual style of questions. Tell me about validation mode. And then the AI component of our documentation will go through all of the various different documentation endpoints and pull together a consolidated piece of information to answer your query for you. And it'll even tell you exactly where it's drawing that information from. So whether you're asking about validation mode or you're asking to generate a random username, the AI agent inside of our documentation should be very helpful to you in pulling together information from various different places across the WireMock Cloud ecosystem and giving you hopefully a very concise and rapid answer to get you to value even faster than before. With that, I think I will open up the floor for any questions. Ask Ethan if he received anything while I've been talking everyone's ears off here, and I'll take a sip of coffee.
Yeah, perfect. This is great, Dan. I hope everyone here sees how powerful the Open API stuff really is and why we're always so excited to talk about it. And I know we're getting close to time, so I don't want to keep anyone too long, but we do have a couple questions and I think a few minutes for them. One question, Dan, would be if you could talk a little bit more. You touched on it at a high level and showed the integration, but talk a little bit more about like the lifecycle loop if I am using that get sync functionality.
Yeah, certainly. So, ultimately, there's always a desire to store things in source code control, and maybe we're collaborating on that. We want to track the version control changes as that specification changes because it is a contract, and we want to know when that contract is changing. And in lieu of version control inside of the platform today, which hint, hint, something we are working on as a product team. But in lieu of lack of that versioning control, the versioning control of the OpenAPI specification or contract inside of Git is quite important. So once we have that initial version, getting that into a state where it's referenceable, it is the one source of truth being inside of your source code control, Git back source code control. Then we can pull that, if it already exists, we can clone that into WireMock Cloud, either manually through the UI once we have that integration set up, or we can clone that on a cron-based basis, right? Maybe you even set up a GitHub action or the equivalent in any source code control. When that OpenAPI specification changes, automatically initiate the one API call you would need to pull that into WireMock Cloud, effectively updating your validation mode, or maybe if you have the auto update of the stubs turned on, allowing you to auto update your stubs automatically when the OpenAPI contract changes. So there's a lot of flexibility in those switches that we've given our customers to determine just what level of automation and automagicness do they want to use when they are using all these features together.
Awesome. Another question to clarify. All that the validation stuff you showed, all of that is within a single API, right? So if I have different APIs at different levels of maturity, I can create different configurations per API based on what that one needs.
Yeah, absolutely. You have one contract, and with the OpenAPI specification contract, you are typically describing a single endpoint, right? A single service. So we would want to honor that and have a one-to-one relationship where one contract to one service. So then you could have discrete mock APIs, all with validation mode turned on, all referencing their own OpenAPI specification documents, maybe even at different version levels, as you have your production version level that you're still using, and then you've got the production +1, the next version of the API that you're also testing earlier stage in your software delivery lifecycle. So absolutely, yes, you would want to separate those out, and we'd be operating on a individual API by API level.
Awesome. And this was not the core topic for today, but just so folks know, what other protocols does WireMock support? So if I had a blended technology stack and not everything was OpenAPI or REST, what else can I do?
Yeah, good question. So the bread and butter of WireMock Cloud today are HTTP, HTTPS services. So those would include your REST-based services, your XML-based services, even SOAP XML, as we do have plenty of handlebar helpers to even address SOAP envelopes and namespaces and such. Those are your core. We can also handle plain text. So think maybe HL7 fixed with character style of datagrams that come over HTTP. We can also handle binary responses. So if we need to send back, account statements as part of a mock API in any type of account history style of mock API, we can send back PDFs. Any binary that can be encoded in base 64 can also come back over HTTP. We also support gRPC as a protocol. It has its own mock API type. And we have basic support for GraphQL today, because after all, GraphQL goes over the wire as HTTP JSON payloads. But as a call out to what we're actively working on now, as I love to do, we'll be introducing some first-class citizen support for GraphQL in the near future. Did I miss any there, Ethan? I feel like I think that was all.
No, I think that's it. I will say, as the product person on the call, we do have a lot of plans this year to plan protocol expansion. So if you didn't hear what you want on that list, please get in touch. We'd love to chat about it. So for all you people out there who are passionate about SOAP APIs, you heard we've got your back on that one. And we do have one more question here. We can cover it real quick, which is, can we do delay in response? If you want the response to take 11 seconds, can we handle that?
Yeah, the answer is absolutely. Every single stub, when you configure it, can have its own delay setting set on it, whether that's a fixed delay or a random delay. We even support something called a chunked dribble delay, which allows you to send the response over multiple, HTTP packets, right? Spacing out how much time is happening between those packets coming back from the mock APIs. A very valid use case for mobile devices hopping across cell phone towers is how I like to say. A lot of our customers are using that. We also have the capability called chaos mode in the product, which when you get a little bit later in your testing cycles and you want to set more of a global delay that is production like across all of your stubs. Remember, a mock API has one or more stubs in it. You could have hundreds of stubs in there. To go and set a delay on each and every one of those manually could be time consuming. So we give you the capability inside of chaos mode to set a more global style of delay that you can match to your production observed response times or production anticipated response times, or even the SLAs that your third party vendor might be giving you for that API that you're virtualizing. And then just to wrap it all up, we have that chaos capability inside of that chaos module as well. Gives you the capability to just randomly change the delay of a response. So perhaps you've configured all responses to come back in 50 milliseconds inside of WireMock Cloud, but every once in a while you want one to take 31 seconds. You can do that with our chaos functionality. Set a percentage of the time that you're interested in having that 31-second delay occur, and WireMock will, statistically apply that percentage to, delay the response by 31 seconds randomly.
Awesome. All right, so I think that will do it for us today. If any of this is interesting to you, you want to chat more about it, maybe you want to get some hands-on one-on-one time about it, feel free to reach out. Our emails are ethan@wiremock.io and dan@wiremock.io, or respond to the email you're going to get with the recording to this. We'd be more than happy to go deeper with you if you want, or talk about any other WireMock Cloud related issues you're having. With that said, you can join us in about a month for the next one of these. Keep your eyes on your inbox for when we announce that. And hopefully everyone has a great rest of their week. Thanks for joining.
Thanks all.